Alright, so this one's about recurring or terminating decimals. So you might recognize this. This is from our full real number system classification. And I've got our non-integer rationals, and the non-integer rationals can be broken into recurring decimals or terminating decimals. So if I write any two numbers as a fraction, I'll get a terminating decimal or a recurring decimal. And so the question is, if I were to write something up on, let's go with two examples, 11 out of 42 and 37 out of 250, or 11 over 42, 37 over 250. Now the question is that a recurring or terminating decimal? And is that a recurring or terminating decimal? So there's really only one thing that you need to realize, two things you need to realize, but the most important one is that it's all about the denominator. Oops, went off the screen. No biggie. Alright, so it's all about the denominator. The numerator doesn't really play a part in this. If I use an example that hopefully you can grab pretty quickly, 1 over 4 in decimal version is 0.25. That's terminating. 2 over 4 is 0.5. 3 over 4 is 0.75. The numerator is changing, but the fact that it's terminating is not. The denominator, the 4 in 1 over 4, is the thing that determines whether it's going to be a recurring decimal or a terminating decimal. Now that denominator has to have something special about it, and the special thing is if its prime factors are only 2 or 5, then it is terminating. But if it's not, if it has other prime factors, then it is recurring. So you'll remember prime factors. You did them way back in year 7. But if I use this one as my example, 11 over 42 is the same as 11 over. And then if I break 42 into its prime factors, let's see. 42 can be rewritten as 2 times 21, which can be rewritten as 2 times 3 times 7. There are our prime factors. You remember prime factor trees. 2 times 3 times 7. Okay, so 2 times 3 times 7. And our little rule here says if its prime factors are only 2 or 5, then it is terminating. Well, this one's prime factors, there is a 2, but there's also a 3 and a 7. So it doesn't fit into our definition. So it's not terminating, therefore recurring. I can put that into a calculator. I can put 11 over 42 into a calculator, and I know I'll get a recurring number. I'll do that in a second. This one, okay, 37 over, let's see, just do a little bit of scratch work here. 250 is the same as 10 times 25, which is the same as, 10 is the same as 2 times 5. 25 is the same as 5 times 5. 2 times 5 times 5 times 5, but I'm a math specialist student, so I'm not going to write that. I'm going to write 2 times 5 to the power of 3, 5 times 5 times 5. Okay, if its prime factors are only 2 or 5. 2, 5. Those are the only prime factors that this particular number has. Therefore, terminating. I better get my calculator out and make sure that I'm not lying. Alright, I typed it into my calculator. The answer is 0.26190476, 190476, 190476, 190476. It's an interesting one because it doesn't start recurring straight away, but it does start recurring. It's 0.2619 and then it starts recurring. 047619, 047619, 047619. So I just put a line above that, and then I can erase the rest. So that bit's like the starting bit, and then recurring, 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 recurring. That bit recurs forever. That one, however, 37 over 250, 37 divided by 250 is a very, very simple 0.148, a terminating decimal. Okay, that's how you can tell whether it's recurring or terminating. You need to reach all the way back to year 7 and think about how to find prime factors.